Thank you. Hello, my name is Adam Warski. I come from Warsaw, Poland, so far away as well. I'm not from academia. My last contact with the university was 18 years ago when I graduated. But I'm still following, all the developments in Scala and partly in functional programming. So it's my second academic conference. It's quite interesting so far. So yes, I would like to try to answer the question how function is direct style Scala and direct style in general. Like we used to program in direct style a long time ago, but then mainly for performance reasons we moved to a more monadic style using futures, IOs, and so on. But now we have some new features in our runtimes and in our languages which actually allow us to go back to direct style. So are we still doing functional programming or not? I would like to start with trying to answer the question, what's functional programming? So this might be like an obvious thing in this conference, or maybe it's quite the opposite. Maybe it's not so obvious at all because it's the functional programming conference. I talked to some people at lunch and they told me it's not an easy question. So yeah, I will try to answer that from like a practical perspective because day to day, like I'm a software engineer. So then we will try to address the question that's here. And finally, I would like to take a look at some purely functional effect systems, whether we can get some of their benefits in our direct style approach. So let's start about what functional programming is in general. So if you go to Wikipedia, we can read that FP is a paradigm where you construct programs mainly by applying and composing functions, right? And that's a fine definition, I guess. But it's also quite vague, right? Because functions, you use functions in all kinds of languages, right? You do C, you define functions all the time. So what does it really mean to do FP? And I propose that we take quite like a pragmatic approach. If you probably go out and ask some people who do FP day to day, like in Scala, for example, but not only, you can do FP now in Java, Kotlin, Ruby, and so on as well. I guess most of the time you would get answers like, we are using higher order functions, you are using immutable data, you are using function composition, you are using functions as first-class values. Of course, your language needs to support lightweight syntax so that it's feasible and so on. So they would enumerate all these tools and techniques that you use to actually do FP. That's opposed to, using explicit loops, having mutable data, combining data and behavior like in the object-oriented style, and so on. So that would be like the non-functional style. I guess the functional programming, as I would define it, is mostly when you are using actually these techniques on the left. But there's also, I guess, two flavors of FP really, and it all boils down to the answer for the question, what's actually a function, right? One way of viewing a function, like the software engineering way, would be that it's like a callable unit of software which has a well-defined interface. You can call it multiple times. But then there's the mathematical definition, right? That for each item from the domain, you assign exactly one item from the code domain, and the function is idempotent and effect-free and so on. So when you are talking about function programming, which of these definitions do you take? And I guess you can actually take both, right? And I would call the first one casual functional programming. That's like a term I invented. And the second would be pure functional programming, right? And I would argue that there's actually a lot of value in the casual variant itself that actually warrants calling it as a separate paradigm, and that is actually very useful. And if we take a look at the degree to which we use functional programming as a kind of a spectrum, you might start with like spaghetti code on the left, so like, just a bunch of imperative code, and then when you try to improve it, maybe, you read a book by Uncle Bob on clean code, so we extract some small methods, right? So we will have the functions already. But I don't think you are doing functional programming yet, right? It's when you apply all these techniques that we talk about, like high-order functions, using ADTs, using expression orientation, and so on, that's when you transform to casual FP, and that's where you get a lot of the benefits from FP. Now, you might go all the way to pure functional programming and get, the additional benefits like referential transparency, but quite often you would only get diminishing returns. And to demonstrate a bit, Here's like 3 snippets of code. So on the left, you would have the spaghetti code version, right? So if you read the code on the left, you don't really understand what it does. But all 3 pieces of code actually implement the same thing. Now, if we move to casual FP in the middle, right, you can see that there's an array of IDs, and then you fetch them from the database, then you do some HTTP, and then you partition it, right? It's much easier to understand than the thing on the left. And it's using, higher order functions, function composition, so some of the techniques that we talked about. And I think the middle version is much clearer than the left one, right? But we didn't go all the way to being pure because we have side effects in our functions. Now we can go the extra step, but we probably don't gain as much. So yeah, so that's how I would define FP by actually more of the practices that you use in your programs than anything that you can, that's very, that has like a very clear definition. So if you are using some of these techniques that are listed here, or maybe most of them, then you're actually doing FP. And I think the distinction between the casual and pure variant actually also might have a reflection in history. So that's one answer from Stack Overflow. Like, I'm not very good in history of programming languages, so maybe that's wrong because the internet is wrong sometimes. But it says here that the original definition of FP came from FP originally came from Lisp, and in Lisp it was more the emphasis on function composition than the purity. And then Haskell came along and kind of tries to redefine and put more emphasis on eliminating side effects. And that's how we get these 2 variants nowadays. Okay, so maybe we know more or less what's FP. What is direct style then? Martin actually gave quite a good definition on the Scala, which is our annual Scala conference in Warsaw. Feel invited if you would have time in April. So Martin defines direct style as the opposite of continuation passing style and using a control monad. So that's kind of a negative definition. So if we tried to say what it is, not say what it is not, I would say that direct style is where the results of an effectful computations are available directly, hence the name direct, right? Directly, so not trapped in a future, promise, IO, or something like that. That also means that we avoid using continuations, right? Either as callbacks or as monadic wrappers. But as I said, we actually need these continuations. We need them for performance, right? That's the reason why all major programming ecosystems moved to using monadic wrappers to represent computations like futures in Java or promises in JavaScript and so on, is because of performance, right? Because we wanted to more efficiently use the resources of the operating system, right? So we still need those continuations. We still need this performance. And we can actually do it. Nowadays, this is often hidden either by improvements in the language, right? In Kotlin, for example, we've got coroutines. So what Kotlin does is it translates the whole program into continuation passing style, and that's how it avoids having explicit continuations in the code or having to use monads. We have virtual threads in Java, which hides the continuations in the runtime. So they are there. You just never directly manipulate them. And we also have like more niche usages such as abilities in Unison or EIO in OCaml, which I think is doing a similar thing. So the continuations are there. They're just hidden now beneath a syntactical shell. But syntax matters a lot because that's how we express programs. Okay, so how functional is direct style, right? Then I guess we are now equipped to actually answer the question. First of all, Scala is functional by construction, right? It is a functional language. We have all those tools at our disposal, right? We have functions as first-class values, ADTs, high-order functions, all with a lightweight syntax. So in a way, we only need a way to avoid spoiling what we already have in Scala. And to kind of compare different approaches, I created a very subjective scorecard of how functional a given approach is. And Scala is uniquely equipped to actually study different approaches to writing programs because we have a couple of ecosystems in Scala. Some of them are purely functional. Some of them are use monads like futures, but they also allow, they are not pure, and some of them are like direct style. So you can actually, using the same base language, you can compare all three approaches. So in our scorecard, what we will take a look at is how well the language supports the given construct. So here for Scala, these are the first three, right? Everything is nicely functional. But then we also have some other categories which actually depend on the ecosystem that you use. So first we've got the purely functional variant of using, if you know Scala, it's using either Katz effect or Zio. So if you use these purely functional effect systems, you eliminate all side effects, or at least you are supposed to eliminate all side effects, because that's done only by discipline, right? When you write code, you are supposed to wrap any side affecting code inside an IO monad or a Zio monad or something like that. But the compiler won't shout at you if you forget to do that. So, sorry. So that's why you don't get top points when it comes to representing effects as values. And we can compare that to like the direct style approach. The language is still the same, but now we get like less points, for example, for effects as values. We still use eithers, which is kind of representing an error as a value, but otherwise all other effects are unconstrained. But all the other scores are quite high. And we can do the same exercise for other languages as well. Of course, again, you might disagree on the specific points, but I guess, you know, we get something like that, where Haskell, of course, is close to being perfect when it comes to functionality, but Scala in both variants is not far behind. So yes, I guess you can tell that direct style is a functional approach because, you know, you can actually use all of these techniques that I talked about quite extensively. I think also what's worth noting is that there are some attempts to do direct style when using the purely functional variant of Scala, but they're all limited, right? So it seems like it's not a concrete, it's not a rigorous proof, but it seems that direct style and pure function programming are at odds, at least when it comes to Scala. Like maybe you could do it, but it would be a different language. So all of these attempts to do direct style when using purely functional effect systems, the way they work is that they take a block of code and they transform it to continuation passing style. However, you can only use a limited subset of the language within the transformation, so you don't get to use the entirety of Scala. Most notably, higher order functions are problematic, which is, I guess, might be quite a limitation. Okay, so as I said, you know, I wouldn't want only to stop like saying if direct style Scala is functional or not. I would also like to take a look at the practical perspective, right? The purely functional effect systems actually give us a lot of functionality that we might want to replicate in direct style. For example, if you're using purely functional effect systems, you get things like safe resource management, like safe refactoring because of referential transparency, like high-level concurrency streaming. You also get some bad sides, like a higher syntax overhead because you have to use the monadic syntax everywhere, the virality of the data types because you end up with IOs everywhere, the learning curve is a bit higher, and so on. So maybe we can eliminate it. So yeah, so the question is, can we actually use the functional programming in the casual variant? And can we leverage, for example, what's in Java to hide the continuations for us? What Java gives us with virtual threads, but keep some of the benefits of the purely functional effect systems and avoid some of the problems. And to do that, we built a proof of concept library called Ox. It's open source. We had a 1.0 release a month ago or 2 months ago. And it tries to implement all the functionalities that purely functional effect systems give us, but in direct style. So a couple of examples. So here we have a high-level concurrency operator. So power will run these two computations in parallel. These computations are passed by name, and it will only terminate when both are completed or when either of them ends with an error. In a similar way, we have high-level operations for racing, timeouts, and so on. We also have a lower-level concurrency API, which is based on structured concurrency. So here you have a supervised block, which delimits the lifetime of the threads created within. So it's guaranteed that when the block ends, any forks that you have created will end. If the block ends, but there are some forks running, they will be interrupted and will wait until they end. So structured concurrency means that the lifetime of the threads the limit is given by the syntactical structure of the code. So for resource handling, we have some utilities like a use function, which automatically loads the resource, but it's not as safe as in the functional systems, because you can still use resources such as a writer here in an unsafe way. So it still relies on discipline, right? It's not a separate type that the compiler will tell you, you have to use the safe variant to actually manage the life cycle. So if you use it with the discipline, it will work fine, but you can still use it incorrectly and it will compile just fine. So then we have some APIs to replicate a functionality of functional streaming transformations. So if you know libraries such as FS2 or Akka streams, so that's the same, but written in the spirit of direct style and with blocking operations in mind. So that's like a streaming transformation. It integrates with some other I/O systems as well. And finally, for the error model, ideally we would want to have an error model with three properties. So we would want to have different constructs for recoverable errors and for programming bugs. So something like panics and result in Rust. We would want to have an indication at call site that an error might occur, and we would want to be able to represent the recoverable errors as part of the type. And one solution here is to use exceptions for the programming bugs, because they like silently propagate. And for the recoverable errors, we might use eithers, which meet most of these points. So you might say that using an either is again going back to using a monad, but either is a very different monad from I/O because it's a simple data type which you can deconstruct, which you can inspect. So either is very transparent, right? As opposed to an I/O or a future, which is very opaque and which you cannot really dissect. So here we're also using Scala's boundary break so that you get the nice syntax without having to use maps and flat maps. And yes, you have the indications at the call site where errors might actually happen. Okay, so to conclude, 1 minute left, okay. I would say that yes, direct style is casually functional, and that although many people insist that functional programming is really about eliminating side effects, I would say that there's a lot of value in FP apart from eliminating side effects, and that we should focus on that part, especially when talking and when advertising functional programming as well, because that's often what buys you the most benefits. If you try to implement direct style, if you would try to implement the benefits of purely functional effect systems in direct style, you actually get a lot of these good points so you can actually keep a lot of the benefits like streaming API, structured concurrency. You get a lower learning curve, you don't get the virality, but also there are of course some trade-offs. So yeah, just 10 seconds. Okay, so yeah, you lose some things such as you don't have you don't have referential transparency, or you don't get the safe resource usage. So my last slide, just a couple of links. It's all on the website. And okay, thank you, and sorry. if I overrun.
For Scala'25 can set up already. Okay. So questions.
Hi, thanks for the talk. I've got one question since the talk a bit about that analysis of what functional style is. Did you think about, I understood that the scorecard you presented was done by hand. Did you think about formal approaches or sort of syntactic, some sort of syntactic analysis or something to giving such a scorecard? Or was it not done by hand?
So like a more rigorous approach to the scorecard. Well, it would be perfect to do it, but I'm not sure how you can do it objectively, so I don't have any good ideas on that. If you do, we can talk later. I would be happy to do it in a more like formalized way. Yeah.
Cool. Yeah, no, that's fair. Thanks.
Okay, thanks. Any further questions? Yeah.
How does a direct style functional programming work when you have like multiple effects? Like I know it for the pure functional programming, when you have an either inside a future, inside another either or something like that, it becomes very complicated to make sure it lines up. What does it look like when you don't have all these like wrappers? Can you still have like error handling inside async, inside something else? And
I guess you don't have any problems with async because you just represent it directly, right? So you do side effecting. So the async is not visible in the type, so it doesn't complicate your types. So you would of course want to limit what you represent in types. I think errors are common enough that you do want to represent them in types. For the other effects, I don't know, maybe capabilities, but currently they are not represented in any way in type. Which is a downside, of course, but it's again the trade-off.
Okay, final question.
Hi, talk. I have a question. So, suppose I have existing Scala code base. It's very purely functional with cats or Zio. Is it possible to slowly introduce direct style into the code base? I guess my question is, can the two work together?
Yes, they can mix both ways. So you can run cats or Zio code in a blocking way, just an operation run sync, and you can use the blocking operator to construct an IO value which has blocking operations inside. So it's trivial to go both ways. And actually, since you asked the question, I forgot to mention Gears. Gears is also a library that Nguyen is working on, which is very similar to Ox. Sorry about that, just because of the time constraint. But be sure to check it out. I think it's in the links as well.
My Maui, how could you? Okay, thank you very much.
Okay, thank you.